Okay guys, I'm in a meeting, but I figure we can still do these notes even though I'm not here because you did them last year. So we're just going to kind of review inverses today. Feel free to ask the sub to pause or rewind if you need them to. Okay, first things first, we need to talk about one-to-one. Okay, remember, one-to-one means for every output, there is only one input. Now remember, a function means for every input, there's only one output. But one-to-one is the opposite. So it's saying for every y you have, there's only one x. An example here of what is not one-to-one, let's look at x squared. Let's say you have a y value of 4. Well, x could have been 2, but it could have been negative 2 as well. So that's an example of something that is not one-to-one because there could have been two different inputs. Okay. Now, how can you tell a function is one-to-one? I'll pause, let you write. Well, the definition is very similar to function definition. And how do you tell if something's a function? Well, we tell from the vertical line test, right? Through any graph, we can draw a vertical line. If it touches only once, it is a function. Well, so if we want to go the opposite direction, we're going to go with the horizontal line test. Okay, so anytime you draw a horizontal line, if it touches the graph more than once, it is not one-to-one. Okay? And the reason we start talking about one-to-one is, well, a function has an inverse if and only if. Remember, that's what IFF means. If and only if it is one-to-one. So x squared we saw is not one-to-one. It technically does not have an inverse unless we restrict the domain. We did this a little bit last year with trig inverse. For instance, last year we had a sine wave. We said, well, that's definitely not one-to-one, but where could we cut it? And we decided we're going to cut it here and make that be our domain from negative pi over 2 to pi over 2. That way it's one-to-one on that domain. And that's how we got that whole, well, I can only look at the right half of the unit circle bit for the inverses. Once again, I may be going fast if you're writing this down, so please feel free to ask the sub to pause if you are still writing. Okay. So let's just jump in then. We're going to determine if the following functions are one-to-one. The first few homework problems I think you have in the book tonight are problems like this. Or they may even rephrase it. I think on one section it says, determine if the function has an inverse. Well, that's saying the same thing. It has an inverse if and only if it's one-to-one. So in the book, if it says, does it have an inverse, it's pretty much asking, is it one-to-one? Okay, so the first one, negative 2x cubed minus 4. Okay, well, we know cubics can be skinny, like that, but they can also be drastic, like that. So our only question is, which one is that? So we do have to graph this one. Ooh, let me open my new calculator. Maybe. Okay. I think this is what I want. We'll see how this goes. And I know you guys either have your old calculators or you didn't bring one. I understand. But the new ones over there, you can use them if you'd like to, or you can just follow along. It boots up, because I know you don't know how to use them yet. Okay. Don't need that. Okay, that's not the one I want. Never mind. I want this one. Maybe. going to go to the graph here. And I changed my window the other day and it's not. It was much bigger. I know it's kind of small. It's a little bigger. Okay, so when I graph here, in F1 I'm going to graph, what was the function? Negative 2x cubed minus 4. So I have my negative 2, where's my x? X to the third, go over, minus 4, hit enter, and there we go. So we see it's really skinny one right there. So in fact, if I draw a horizontal line anywhere, it's only going to touch once. So it is in fact 1 to 1. Now this one we should not need a calculator for, because we know this is absolute value. That's just a line. Now remember what absolute value is. Many of you will think of a V, which is true. However, what it means is I could graph the line 3x minus 1. So it looks something like that with a slope of 3. And what absolute value means is take all the negative part and flip it up. So my function is actually just this. That's how we get the V. It's taking the negative and making it positive. So looking at that absolute value, if I draw a horizontal line, it's definitely not 1 to 1. Two to the 3x. Now you really should need a calculator on this one, but we'll graph it just to double check, because this is an exponential function. Much like e to the x, you should know what an exponential function looks like. Okay, so try to picture it in your head, but we'll graph it just to double check on this one, since you may not remember. So I'm going to go back up and erase the last one. And I think it was 2 to the 3x maybe. Here we go. That's what you should have been picturing, that exponential. Remember that Valentine's card I told you about, that my love for you is exponential? It grows rapidly, quickly. Okay? So if I draw that horizontal line, it's only going to touch once. Now some people look here and say, well, it'll touch a bunch of times. So remember, if I zoom in, it's getting closer and closer and closer, but it never actually levels out. Okay? So it is a yes. It is 1 to 1. Okay. All right, now then let's jump in, and we've determined how to tell if a function is 1 to 1, and we know that in order to have an inverse, it has to be 1 to 1. So let's go ahead and actually find inverses. So how to find F inverse? First, solve for x. If you can, arrow diagram it. And then 2, interchange x and y. So wherever you have an x, switch it with y. Wherever y, switch with x. Okay, so solve for x, interchange x and y. So here we go. We're going to find the inverse. Find the inverse. F of x equals 4, x minus 2, quantity squared, minus 1. Now remember, if there's only one x, you can arrow diagram. And Alex, I know you're not an arrow diagrammer. Feel free to come in after school. I'll show you how to do it the old-fashioned way, which you're more than welcome to do. I'm going to replace this with y to make it easier. Okay. So I have one x, and what do I do to x? Well, I'm subtracting 2, then I'm squaring it, then I'm multiplying by 4, subtracting 1, and I get y. Then I add 1, divide by 4, square root plus or minus, and we'll talk about that in a second, plus 2. Now, let's go back and talk about that. Remember, when you're doing an arrow diagram, you have 2 answers, okay, for a quadratic. We forgot that a lot last year. However, with an inverse, let's think about it. If I were to graph a positive square root and then to graph a negative square root, there's a problem. That's not a function, does not pass the vertical line test. So when we're doing inverses, we really don't worry about the plus or minus. We just leave it as kind of the positive one. Okay, so now I look backwards. I have y plus 1, all divided by 4, all under that square root, all plus 2, and that equals x. So next thing I'm going to switch x and y. So wherever I have a y, put an x. Wherever I have an x, put a y. And we're big kids, we should be able to jump straight to inverse notation instead of y. Because I technically didn't even have a y on this problem. There we go. Just make sure you clean it up as much as you can. Let's do another one. Find the inverse. Find the inverse of f of x equals 5 minus x over 2x plus 7. So we did these last year. It's very important that we still remember this process this year because we're going to get something called implicit differentiation, which uses this exact same process. Notice I have 2 x's. Whenever you have 2 x's or if you have an x on the denominator, you cannot do an arrow diagram. You have to use this process. So let's bring it back. I'm going to replace that with y. So I have y equals 5 minus x over 2x plus 7. I'm going to put it over 1 and cross multiply. So I get 5 minus x. And go ahead and distribute your y. I think we're big enough kids we can do that without messing up. Give it to both. Now from here, remember I get all my x's on one side, everything else on the other. So I'm going to try to keep x as positive as possible. I'm going to take this over. Then I'm going to take that over. So I really have 5 minus 7y equals 2xy plus x. So I took that x to the other side, I took that 7y to the other side. Now that I have x's on one side, everything else on the other, I'm going to factor out my x. So 2y plus 1. And then my goal is to get x by itself, so I need to divide by all that junk. So I have 5 minus 7y over 2y plus 1. Now I have x by itself. I need to switch x and y. So I have 5 minus 7x to x plus 1 equals y. And I'm going to go ahead and write that with inverse notation. And yes, I do want you to write it with inverse notation. You can if you want to go straight from here to here, if you're comfortable with it. Voila. Hopefully that process comes back to us. Cross multiply, get all your x's on one side, everything else on the other, factor, and divide. Okay, so now you try. Obviously we can't use the clicker since I'm not there, but I want you to work this problem. I'm going to ask the sub to please pause the video, because I want to give you a few minutes to work, and when everyone else looks like they're done, go ahead and hit play again. Okay, so I'm going to set that equal to y. Put it over 1. I'm going to cross multiply. So I have 3x equals 6y minus 2xy. I need all my x's on one side, everything else on the other. So I'm going to take this over. So I have 3x plus 2xy equals 6y. Factor. I have 3 plus 2y. Now I want x by itself, so divide by all that. So I have 6y, 3 plus 2y. And I'm going to go straight to my inverse notation. F inverse of x, switch x and y, 6x 3 plus 2x. Hopefully we did okay, because we did all this last year, so hopefully it's coming back to us. If not, remember, I am here after school. Now, another part of inverse is not only finding them, but verifying them. Do you remember how you verify? So f is an inverse of g. If f composite g, so f of g of x, remember that's what that means. It's not fog. And g composite f, which is g of f of x, is x. Okay, remember this is when you take one function, plug it into the other, simplify it, you should get x. Then you do the same for the other one. You put the other function in the one. Simplify, you should get x. Now remember, you can only cancel one thing at a time. So I think we have one of these and then we're done. Yep. Let's go ahead and do one. Okay. So verify f and g are inverses. Verify that f and g are inverses. So f of x is negative 3x cubed plus 10. G of x is the cube root of 10 minus x over 3. Now, to verify this, we're going to find the compositions. It is not okay for you to take one of these functions, error diagram or do some algebra, and find the inverse and say, yeah, look, it matches. That's not verifying anything. Okay, we need to find the compositions. So, I'm going to first find f composite g, which means I plug all of this in for x. So I have negative 3 cube root 10 minus x over 3 cubed plus 10. So I plugged all this in there. Okay. Now, here's what I don't want to see. Cancel, 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 something like that. And then equals x. No. That's not showing me anything. Okay, so one thing at a time. So the first thing it does cancel is my cube root and my cube. So I have negative 3, 10 minus x over 3 plus 10. Next thing that cancels is my 3's. Now here's where a lot of you guys tried to fudge this last year on a quiz. I remember this specifically. Because you just tried to magically make your negative kind of go away. But I have to distribute, so I have negative 10 plus x plus 10, cancel, cancel, I get x. So this side worked. I'm going to scroll back up. And now I need to do g composite f, which means plug all this in for x here. So the cube root, 10 minus, make sure you have parentheses, they have 3x cubed plus 10 all over 3. Okay, so let's see, let's distribute first. I have 10 plus 3x cubed minus 10 all over 3. 10's cancel first. Then my 3's cancel. So the cube root of x cubed, so my cube root and my cube cancel out. I get x. Voila! Remember, one step at a time. It's just algebra. Okay, so your homework is 1.5 day 1. Now, I think most of these, I think maybe 1 through 12, is just, is it one-to-one or does it have an inverse, which is asking the same thing. So a yes or no answer is fine there. Okay, that's all you have to put down. And these are finding inverses. Shouldn't be too tough, but if all this doesn't sound familiar or you're struggling with it, I am here after school today, so make sure you pop in and get help. Okay, so right now, you're going to get the popsicle sticks, get some partners. I have a handout for you to work on. If you finish the handout, check it with the key that I've hopefully left, and then work on your homework with your partner. See you tomorrow.